हेलो।
Hi guys, can you see me and can you see the screen? Hello guys, can you hear me?
यस यस।
We'll start in 2 minutes. Please post on the group someone.
एक्चुअली एक पूछना था कि जो इंटरव्यू में कोडिंग के पाइथन कोडिंग के अलावा सिक्वल का भी पूछता है ना क्वेश्चन।
हाँ पूछ सकता है।
तो उसके लिए बहुत प्रैक्टिस करना पड़ेगा।
तो प्रैक्टिस करना पड़ेगा ना, क्वेश्चन सॉल्व करना है।
तो उसके लिए भी कुछ लिस्ट रहेगा क्या आपके पास क्वेश्चन, ताकि मतलब एक लॉजिक बिल्ड हो जाए।
तो क्वेश्चन का लिस्ट नहीं है, सीक्वल का जो कॉन्सेप्ट्स है ना।
कॉन्सेप्ट तो पता है, लेकिन ना थोड़ा सा वो
कोई
अ,
डमी टेबल ले लो, उसके ऊपर ईडीए करो, प्रैक्टिस करो, एक्सप्लोरेटरी डेटा एनालिसिस करो, या फिर मैं बता दूंगा एक वेबसाइट है, वहां पे प्रैक्टिस कर सकते हो। लीड कोड पे भी मिल जाएगा, हैकर रैंक, हैकर अर्थ, ये सब वेबसाइट है ना। इसमें
हम्म,
जाओगे तो सीक्वल का बहुत सारा, जैसे लीड कोड डीएसए का क्वेश्चन है, तो वैसे उस पे मिल जाएगा, प्रैक्टिस कर सकते हो। स्ट्रैटा स्क्रैच बोल के एक बहुत अच्छा वेबसाइट है, उस पर देख सकते हो।
कौन सा।
हैकर रैंक पे जाओगे ना, यहाँ पे।
बैंक में तो कुछ क्वेश्चन है, उसको तो किया हूँ।
बहुत सारा, कुछ क्वेश्चन नहीं, बहुत सारा क्वेश्चन मिल जाएगा। हैकर रैंक है फिर। स्ट्रैटा स्क्रैच बोल के एक वेबसाइट है, मैं कभी देखा था काफी टाइम पहले। उसमें जाओगे ना, यहाँ पे जाओ, देखो। डेटा एनालिस्ट, डेटा साइंटिस्ट करके बहुत सारा क्वेश्चंस है, कंपनी वाइज भी है। सीक्वल, पोस्टग्रेस, जो भी चाहिए। पांडास का भी प्रैक्टिस है। यहाँ पे जाके ऐसे जाओगे ना, यहाँ पे देखो टेबल दिया रहेगा, क्वेश्चन दिया रहेगा, यहाँ पे आप अपना क्वेरी लिख के प्रैक्टिस कर सकते हो। ठीक है। वैसे ही हैकर रैंक पे भी मिल जाएगा, लॉग इन करके एक बार देख लेना। सब लोग आ गए क्या? Guys, can we start with the session? Can someone please put it on the group? So, guys, what were we doing in the previous class? Can someone quickly remind me?
Stuck, you teach something
हाँ,
like a stuck topic.
कौन सा टॉपिक?
A stuck,
पैक
yeah, stack.
पैक पढ़ रहे थे हम लोग. ठीक. Hello, check. Guys, can you hear me?
Yes, yes.
Yes, sir.
Okay, sorry about the disturbance. Did we do any assignments last time? Did anyone try out the assignment that I gave? We discussed the implementation of stack. What did we discuss? Can someone summarize it for me? No one? Guys, come on. Are you able to hear me? Have you tried or not tried? Yes or no? It's a yes or no question. Did you try out the implementation of stack? Not yet. Why? Okay, we will try to do it today. So we discussed that if we want to implement a stack, there are three ways in which we can. Guys, if you have not attended the class, then you have one full week to watch the video, no? See, ultimately you have to do it. I have done it 5 times. It is very easy for me to just write the code and move on, but you have to try it out.
Let us do implementation of stack. Did you understand did those of you attended the class, did you understand the concept of a stack? Guys, please respond. I can't talk much. I'm having a very bad throat infection. You have to tell me. Okay, I'll move ahead. I'm creating a new notebook and I'm calling it stack and queue. Okay. So let us do an implementation of stack. Okay, so if we talk about implementation of stack, we discussed that we can do it using a list in Python. Okay. And what was the second method that we discussed? Using a linked list. And the third was using a deck. So I think we did not discuss the linked list and the deck part, but we discussed the list wala part, right? So let us first do using a list. You will get an idea of what I'm talking about. Okay. So if we talk about ADT, ADT of stack, what were the main methods in the ADT of stack? We need to push, we need to pop, and we need to get the size, and we need to seek, or we can say top. Correct? We need to check if the size, what is the size of the stack. We can have some helper methods also, which are like is empty or is full. Is empty and is full will be relevant when we are having a stack of a given capacity. It is up to us. We can have a stack of dynamic nature also. We can have a stack which is having a fixed capacity. Both possibilities are there. You know about the concept of a low level array and a dynamic array. So accordingly, we will be able to adjust it. Okay. All of you are here with me till all of you are with me so far. Okay. So let us do a implementation of stack. Why is the webcam not working? We'll create a class called stack. Okay. And what are the methods that we want to have in this class? Okay. This will be, I'll call it, let me call it a list stack. Okay. Just to differentiate it from the other methods. And this is a stack implementation using a list. Okay. So we'll have an init method. Okay. So I told you that when we are using a stack using a list, okay, under the hood, we will use a list, but the interface will be of a stack. That is the whole idea, which means I told you that we are using a list. So behind the scenes, we are using a list internally, but from a user perspective, we are going to encapsulate it, and the user will be able to use only the stack properties. So I'm going to say self dot list, and I will create an empty list. Okay. So underlying data. Now this, we don't want the user to access this one directly. So Python, we can make it as a protected variable, or we can make it as a private variable. So I'm making it as a protected variable, so that the user will not be, at least there is an indication that user is not supposed to access it. Okay. Then next, what we want to do, we want to add a method for pushing the data. So I'm calling it push. So when we are pushing the data, we'll take some value from the user and we want to push it. Okay. So what will happen? What is this going to do? This is going to push a value on a stack. So I told you that a stack is very, very similar to a list in terms of pushing. In a list also we will append it. So in a stack also, if the user wants to push a value, then he can simply say self dot underscore list dot append, I'll say value. Okay, are you guys following? It is as
Yes.
simple as that. Then what is the next one? We want to pop a value. So I told you that stack, we want to pop a value, we'll remove the value from the end. So if we remove the value from the end, we already remove the value from the stack, from the top of stack. So remove the value from a stack. By default, it means it will be top of stack only. Okay. So what we will do? We will say self dot list dot pop like this. Okay, and this we are going to return. But here there is a edge case. It is possible that the list is empty or the stack is empty. So we'll check if the stack is empty. Okay, so we'll say if self dot is empty, in that case we will raise some exception, means there is no value in the stack and we are trying to pop it. So in that situation we will just raise an exception. So exception will be the stack is empty. Okay, so this method of is empty, this method we have not written yet, so we have to write this method. So for now I am putting one placeholder here.
But here parenthesis you missed that.
कहाँ पे?
Empty,
हाँ,
yes.
ठीक है, अब ठीक है.
Yes.
पॉप, ये मेथड हमने लिख लिया. और अब नेक्स्ट मेथड क्या लिखना है अपने को? वी हैव डन implementation using a list. Methods needed are push, pop, peek, and size. Size is optional. It is up to you if you want to add it. So let me write a method called seek, or let me say top.
सर ये जो अपेंड पॉप या फिर रिमूव जो भी मेथड है लिस्ट
हाँ,
का, वो
हाँ.
मतलब बिहाइंड द सीन क्या यूज करता होगा? सेम लिंक
अरे है
लिस्ट
ना, अरे है
है?
ना, अरे होता है ना.
नहीं नहीं, हाँ, तो जो डॉट अपेंड या डॉट पॉप यूज कर रहे हैं हम लोग, या डॉट
हाँ, हाँ.
रिमूव यूज करेंगे, वो बिहाइंड द सीन क्या यूज कर रहा होगा?
कहाँ पे? ये लिस्ट में?
नहीं नहीं, अपेंड जो मेथड आपने लिखा है
कहाँ
वो
पे?
मैं पूछ रहा हूँ।
ये वाला?
हाँ,
ये तो
ये क्या
लिस्ट
यूज
का
कर?
अपेंड है ना, नॉर्मल जो लिस्ट होती है.
अच्छा।
लिस्ट होती है ना, लिस्ट में डायनामिक एरे में हम लोग अपेंड करते हैं ना, नेक्स्ट मेमोरी
हम्म
एड्रेस में डाल देते हैं.
हम्म
डायनामिकली ग्रो होता है, जब वो साइज भर जाता है तो नई मेमोरी लोकेशन पे जाता है. हमने डायनामिक एरे में पढ़ा है ना वो सब.
हम्म
तो ये
हम्म
डायनामिक अरे ही है. तो एक डायनामिक अरे को यूज करके हम लोग एक स्टैक बना रहे हैं.
हम्म
तो आप बोलोगे कि ये जो पुश मेथड है, अपेंड मेथड, ये तो एक ही है, तो इसके लिए मेथड क्यों बना रहे हैं? लिस्ट ही यूज कर लेते हैं,
हम्म
है ना. तो लिस्ट इसलिए नहीं यूज कर रहे क्योंकि लिस्ट में और भी फंक्शनैलिटीज होती है. तो लिस्ट के कुछ फंक्शनैलिटीज हमें यूज करनी है, सारे फंक्शनैलिटीज नहीं यूज करनी.
हम्म।
इसलिए हम लोग लिस्ट के ऊपर एक एब्स्ट्रैक्शन बना रहे
नहीं, लेकिन ये हैशटैग का हम लिख क्यों रहे हैं? इसका प्रोग्राम मतलब लिखने का पर्पस मतलब क्या है?
हैं. लिखने का पर्पस ये है कि आपने स्टैक पढ़ा और अब हम लोग एक स्टैक बना रहे हैं.
नहीं, उसका रिक्वायरमेंट नहीं है ना?
क्या?
नहीं मतलब नॉर्मल। अच्छा, एक्सट्रैक्ट का एक प्रोग्राम लिख रहे हैं क्या?
प्रोग्राम ही लिख रहे हैं ना.
स्टैक में जो भी ऑपरेशन होता है उसको हम ऑपरेट कर रहे हैं।
बना रहे हैं हम लोग एक स्टैक को पाइथन में इम्प्लीमेंट कर रहे हैं. जैसे एक एरे होता है वैसे ही एक हमने लिंक लिस्ट बनाया,
हम्म।
तो वैसे ही हम लोग स्टैक बना रहे हैं. आगे चल के हम लोग ऐसे क्यू बनाएंगे, आगे ऐसे चल के ग्राफ बनाएंगे, ट्री बनाएंगे, डेटा स्ट्रक्चर जो यूज होता है वो बना रहे हैं हम लोग. है ना. तो टॉप. सो इफ यू वांट टू इफ यू वांट टॉप, देन व्हाट वी विल डू? This will remove and return. Okay, if you're doing top, So it will not remove, it will only return the value from the top. तो अगर stack को, if you are imagining a stack like a list, and if you want the last value, then what you will do? Last value will return. Okay. Again, here you can have a check that if self dot is empty, just give me 1 second, guys. Yeah. We will check that if this is empty, again we will raise an error. You can write your custom errors also. I think in Python class I showed you, so you can write your own exception, stack overflow, stack underflow, that kind of exception you can raise. Okay, this is done, and then we want one more method. At any point of time I want to find out what is the size of my stack. Okay, so if you want to find the size of a list, what do? You simply give length function you are using. So internally, because we are also using a list only, so simply we can say self dot list. Okay, to get the size of the stack. All of you guys are following till here, guys? यहाँ तक सबको समझ में आ रहा है? इसको मैं ब्लैक थीम कर दूं क्या? Is this better for you guys to see?
Yes, yes.
Or the white one is better?
कोई भी चलेगा सर,
हाँ,
कोई भी
कोई भी
चलेगा सर।
हाँ, ठीक है, white is better. Okay. Did you guys understand this, what I have done? Now, in order to use this, we will have to, now we can create some stack. So I'll say my stack. I'll say my stack is a list stack. I have to run this list stack. Okay. So if we have done this, then
Again, you missed the parenthesis.
sorry,
Again, you missed the parenthesis here.
where?
The top methods.
Oh,
Yes.
sorry. I'll say we have done this. We have created now one stack. Okay. Now on this stack, you can do some things like we can check dot size. So size of my stack is 0. Now, if we have a stack, what can we do? We can push some elements and we can pop some elements. By the way, when we are popping the element, what is the time complexity? What is the time complexity? It is O of 1. When we are pushing also, it is O of 1. Now this method we did not write, so we can simply return self dot size is equal to 0. ठीक है ना? All of you are able to follow till here, guys?
Size is method actually, no? Right?
Size
method है क्या?
Size method है.
Attribute, right? हाँ,
method है, लेकिन अगर आपको ऐसा लग रहा है कि ये मेथड नहीं एट्रीब्यूट होना चाहिए, तो आपको सही लग रहा है, क्योंकि साइज एक एट्रीब्यूट होना चाहिए.
Correct.
तो इसको अगर एट्रीब्यूट बनाना है, if you want the size to behave as an attribute, then what can we do? I taught you in OOPS class.
Yeah, we can use the
property
constructor.
decorator. Property decorator. If you use property decorator, method can be accessed like a attribute. So here I have written as a method, but if you want, you can create a getter, and then it will not behave like it will be a method, but it will behave like an attribute. ठीक है? So stack, we have created one empty stack. Now what I want to append some value. So I want to append 10. List of has no attribute. So see, can we append to my stack? Am I making a mistake?
It will be pushed actually.
It will be push because there is no append in a stack. Okay, append happens in a list. That's why we created this abstraction over list, that we cannot use append. If we are using a stack, then we have to do push. Okay, this is important. All of you guys are understanding. Now behind the scenes, it is append only. As far as implementation using list is concerned. गरम है? हाँ दे दीजिए. बहुत गरम है. Okay, so we can do push. So if we do push, and again if we check the size of size of the stack, you see now the value is 1. But we are not able to visualize this stack because we have not written any method to visualize it. If we create a list, we are able to visualize the list. But in the case of a stack, we have not written. Now, visualizing is not very important. But because we are creating our code, that's why we will write something to visualize it also. So what method we are using? We are using a string method to visualize. Okay. So before this, what we can do, we can write one method that will convert my stack to a list and a list to a stack. So you know that when you have a tuple, you can convert a tuple to a list to a tuple. So something very similar, I want to write one method that will take my stack and it will convert it to a list. Okay, so I can do it very simply. I can just say return list of self dot list. Now you see why I am not returning self dot list here. Why I'm doing list? So I'm creating a shallow copy. Okay, so that we don't modify. It is returning a copy. So if we want to create a string, we can simply say return, and you can imagine how you would want your stack to behave, to be visualized. Okay, so when I was drawing the stack, I was drawing it vertically. So I will try to create visualization here also vertically. Again, this is not at all important. Just for fun, we will have something like a good visualization. What we can say? We can say x for x in self dot list. Okay, this will create a list, and I want to have it as a string. Okay, string. And I want to join it. So I want to join with what? I want to join it with plus /n. Let me see if this will work or not. Dot join. Okay. Let me have the same method for REPR also. Okay, so now we have created this. Now you see I'm having a value 10. So it is visualizing. I'm able to visualize it. Now again, I want to push some more value. Let me say I want to push 20. 20. 10, 20. कैसे आ गया ये? इसको ऐसे कर दूं क्या? थोड़ा सुंदर लगना चाहिए देखने में. हाँ, ठीक है. Let me make it normal dash. So see, we are having 10 and 20, but 20 should come up because 20 is the top, right? तो इसको reverse कर देते हैं. Okay, 20 आ गया. I want to push some more values here. So I want to say 30. I want to push a 40, and then I want to push a 50. You see, this is my stack. This is not a very good way to represent it. If you're having a long one, then it will cause problem. But we are simply doing some trial for that reason. This is how our stack looks. Now, what other method we are having? We are having pop method or seek method also. Seek or top, which one did we write? Top. Okay. So if we do my stack dot top, okay, so you see 50. And again, if we look at my stack, you see it has not deleted anything, it has just returned the value. Now we can do dot pop. Okay, so see, we have done pop and it has returned 50. Now if we go, the top will be at 40. Again, if I do pop, it has returned the value 40. Again, if I do look at my stack, it is 30. I can do a pop, it will give me 30. See, it is now 20 and 10. If I do a pop, it is 20. Now there is only one value. If I do a pop again, you see, now there is nothing in the stack. Okay. If I do is empty, okay, again, this is empty method is to be used internally. It is your decision whether you want to keep it or what you want to do. You see, now it is empty. Now again, if I do pop, I should get one error. See, I'm getting an error that stack is empty. If the stack is empty, I should not be able to pop anything. Guys, are you following? समझ में आ रहा है सबको? ठीक है? So this is stack implementation using list, which is very simple. Anyone having any questions? Now, what is the next implementation of a stack? What will be the next implementation of a stack?
I think using implementation
हाँ, आवाज नहीं आ रहा, जोर से बोलिए.
stack using
Sorry,
linked list. Yes.
using a linked list. Okay. So how can we use a linked list to implement a stack? Here you can do few more things which I have not done. Okay. For example, you can decide that my stack will have a capacity. Okay. So you want a stack to only have maximum 10 elements or 15 elements, 20 elements like that. So that is also possible. That also we can do.
At what method do we use, sir, for those?
Sorry.
At what method to apply on those 50 or 40 limit?
You tell me.
I can set some variable to depend on method and compare it.
Like what? Be be more clear in what you are trying to say.
No, for examples, I want to set maximum element as 50 from the stack.
Yes.
Okay, I'm going to set with one initialize one variable with holding the 50 values.
I can have like a capacity here.
Yeah, capacity. Yeah.
Okay, this will be capacity.
Hmm.
And here you can add a capacity.
Yes, we will pass the capacity.
Capacity may be 100. Okay. While creating the stack, you can give a capacity. Then when you are pushing, you can check if the size is less than equal to capacity. If the size is less than capacity, then only we will push. If the size becomes equal to capacity, then we will give an error.
Okay.
Okay, that we can do. That also is possible.
Yes.
Now we have to do implementation of a stack using linked list. So how can someone tell me based on your knowledge of linked list and based on your knowledge of stack? And see, these questions are very commonly asked to test your knowledge. Implement a stack using queue, implement a queue using stack, implement a stack using linked list, implement a queue using linked list. Okay, these are commonly asked questions. So you have to be very clear. You have to be very clear in this. So can someone tell me how you will implement a stack using linked list?
Uh, we will define the stack value, stack first of all, then define the linked list as well.
What do you mean
Then
define the linked list?
define the linked list, we can create one class, right? Linked list class.
Okay.
Okay. Then after that, the next step should be we have to create a node to create one more class per node. So these are the we have to create three classes. The step number one, we need to construct the classes. Okay, the step number two, we need to map it, right, into the stack. The stack is abstract data type. We need to map it. We need to
You're giving
define
a
the
very
necessary.
generic thing. You're not telling me exactly what is to be done. How will a linked list behave like a stack?
Mm,
Based on your answer, can someone create this?
mm.
You tell me.
But I think it's underlying the bottom container is nodes. Okay. No,
But
is whatever we have written in the top of in the top right. The similar way we can write it, and we need to
again,
insert the node.
you're not giving the answer to the question.
Mm, okay.
Based on your description, can I do this work? No.
Hmm.
You're saying we'll create a class and we will map it. I mean, yes, we have to do that, but how? So if we are having a stack, what do we need in order to create a stack? We need to have a push, we need to have a pop, we need to have a seek.
Yeah.
Okay. So if we
Yes.
create a linked list, okay, we create a linked list, then how will we do push? Okay, we want to add something to a linked list. So can we add the new value to the head of the linked list? So we will
Hmm.
treat, the approach is that we will treat we will treat the head of the linked list as the top of the stack. Why we will treat the head of the linked list as top of the stack? Why not tail? Because we want to ideally do this push in O of 1. Okay. So in a linked
Hmm.
list, if we want to push, add a new element, if we have the head, then we can do it in O of 1. If we want to do it in tail, then we have to keep track of the tail. So tail also we can do, but we'll have to keep track of the tail pointer. Okay. And if we have to pop, then also it will be a problem. Okay, because then you have to have a doubly linked list. So if you have a singly linked list, then we can simply treat the head of the linked list as the top of the stack. Then we will be able to add a new element. It will be no often. If you want to pop element, remove the head, remove the head of the linked list. This also can be done in
Okay.
O of 1. Okay. If you want to seek, then also return the value of head. This also can be done in O of 1. Okay. And size is empty, is full. All of that you already know we have done in the linked list implementation. So if someone is asking you that how are you going to implement a stack using a linked list, you can say that a stack for implementing a stack. One second, please. For implementing a stack, we need push, pop, and seek. If we are able to implement these three things, then we can achieve a stack. If you want to achieve a stack using a list, then push and push can become append method of a list. Pop can become the pop method of a list. Seek can become the last value index of a list. If we want to implement linked list, stack using linked list. If we want to implement stack using linked list, again we have to implement push, pop, and seek. So in order to push, which means to add a new value, we can add the value to the head of the linked list. Because adding something to the head of a linked list is O of 1 operation. Adding a value to the head of the linked list means link adding something to the beginning of the linked list. Okay. Pop, if you want to do pop, then we can remove the head and shift the head onwards. Now, can someone tell me how this will work? How we can add a new value to the head of the linked list? Can someone help me?
Yeah,
What is the way?
yeah. New node equal to
How can we add a new value to the head of the linked list? We'll simply point the next pointer of the node to the head, and we will shift the head to the new node.
correct
All of you are clear? So let us create a class called linked list
link list.
stack. Okay. So we'll have one init method. This is, I will say, implementation of linked list using a stack. Guys, you have already learned the basics. Now you have to use your knowledge to apply it to different situations. That is only DSA. Whatever you know, that you have to apply in the different situations. If you're not able to apply, that means you have not understood it properly. Memorizing these things is not going to be of any help. You have to understand what we are doing, why we are doing what. Okay. So what we will do here, first step will be, we will create a stack. So if we are creating a stack, basically we are creating a linked list, because the stack behind the scenes is a linked list. Okay. But the user will not be able to access the linked list portion. He will again access push pop. So I will show you that whatever code I have written here, same code is going to work. Same code is going to work even if we are doing linked list stack. Okay. The interface will not change. Implementation will change, but interface will not change. We can exchange list to linked list to queue to deck. There are different ways. All of those can be switched, but the outside interface is going to be identically same. Okay. So I'm going to say init method. Init method. I'll say self. I'll come here and I will say what we will do. How do we initialize a linked list? We'll say self dot head is equal to none. Okay. I will say self dot size is equal to 0. Now this head the head is none. Okay. Size is 0. Now why am I using the head as a protected variable? Why is this as a protected variable?
We should not access from
Because
other class.
because the user who is going to access my stack, he has no business with head, tail, or other things. Okay. He should not access. Now, can he access? Yes, he can access, because this is protected. It is not private. But if we add an underscore, it is an indication for him to not use it. He is free to use it, but it is an indication that he should not use it. Now it is your choice. You want to make it as a private variable, you can do that also. Now, in order to create a linked list, we also need to create a node. So node is very simple, nothing. We'll just say self dot, we'll create one init method.
Self up node, self command node.
We'll say self dot data is equal to, इस पे data डाल देते हैं. Self dot data is equal to data, and self dot next is equal to
Next.
none. Okay. Now we have done init. Now we have time to write the push method. So when we write push method, we have to take self and we have to take value. Okay. Now what we will do here? Okay. Pushing an element to a stack. Okay. So what we will do?
In
We
this
will
case, we
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 always
need to
have
find.
बोलिए एक आदमी बोलिए.
want to understand. In this case, we always have to move head so that push and pop can be done at the head only, right? For
Correct.
any. Okay.
Correct. we will insert the element at the
Into
beginning
next beginning.
of the linked list. Okay,
Yes.
guys, all of you are able to hear me clearly.
Yes.
Audio is fine, no? Okay, chalo.
Yes.
We will do push. So what we will do here? You remember the code that we did for pushing? First, we will create the new node.
Yeah.
First, we'll create the new node. So how will we create the new node? We'll say node is equal to node, and we'll give the value. So value user has given us. Now what we will say? We will attach the next pointer of the node. We'll say node dot next is equal to self dot head. Okay.
Head.
Then we'll say self dot head is equal to node. Okay. And we'll increase the size. Simple.
Yeah.
All of you are clear? So
Yes.
now you see, I want to emphasize on this thing. When the user is using this stack, he will simply do push and value. All of these things is happening behind the scenes. Okay. O of this is going to be O of 1. Now, if the user is using this stack, then also he will do my stack dot push. If he's using this one, then also he will do my stack dot push. But one implementation is using list, another implementation is using linked list. So you are able to appreciate how implementation can be different, but interface is same. Okay. I hope you are able to understand abstraction concept of OOPS.
Yes.
Okay. Now what we have to do? We have to do pop method. Are you able to see the screen properly? It's pop method. So pop method, what we will do?
Yeah.
We will remove and return the top element
The top element, the first element
of the stack. Okay. This also we want to do in time complexity of O of 1.
Yeah.
What we will do here? First, we have to return the head. So we'll take the value and store it somewhere. We'll say self.head.data. Okay. Then what we'll do? If we have to remove the first element of the linked list, then what we are doing?
We need to directly we need to point the self.head equal to none something.
If you do self.head is equal to none.
No, we need to point head into the next
we
node.
We will move the head to the next node, correct?
The
no?
next node.
Self.head.next.
Next.
Okay. And we'll reduce the size because we have removed one element. So size will become minus equal to 1. Then we will return value. Okay. All of you are clear, but there is one edge case in this. That what is the edge case? If the stack is empty.
Stack empty.
We'll say if self dot is empty. We have not returned the is empty method, so we will write that. We'll say is empty. We'll say pass. Okay. We will do that later. So if it is empty, then what we should do? There is no element, but we are trying to pop an element. So what we will do? We can raise an error, index error, whatever error you want to raise. Exception. The stack is empty. Clear? Then what is the next method? We'll write one more method which will be peak.
Seek method, seek or top.
Top method, okay. So what will happen in top?
We have to return the top element, first element.
This will only return the last element. You want to return only the last element. Then what is the last element?
Head element. Head. No.
Self.head.data. Again, we can make one check here that if it is empty,
raise exception.
if there is no element, then we can simply raise one error. Now we want to write this method. If we want to check if there is no element, check if the stack is empty or there are no nodes in the linked list. How can we check this?
Okay.
Priyanka, you're raising your hand. Do you have a question?
Yes, sir. Yeah.
Please tell
So
me.
when we are removing the element, you said the head, we are shifting to the head dot next, right?
ठीक है?
तो जो भी पहला नोड था, मतलब जो हम पॉप कर रहे हैं,
हम्म
उसका नेक्स्ट अभी भी हेड, मतलब जो नया हेड बना है उसको ही पॉइंट कर रहा है, राइट? फिर दैट एलिमेंट शुड इज स्टिल एग्जिस्टिंग इन, हमने सिर्फ हेड शिफ्ट किया, बट हमने
हाँ ठीक है, हेड को शिफ्ट किया, लेकिन आप बोल रहे हो जो एलिमेंट पहले हेड था उसको हमने डिलीट तो नहीं किया,
डिलीट नहीं किया, फिर उसका
वो
नेक्स्ट को
अभी भी
नल कर।
वो अभी भी हेड को
हाँ,
पॉइंट कर रहा है,
नहीं, वो हेड को पॉइंट नहीं करा आपने, तो उसको नेक्स्ट वाले को हेड बना दिया, राइट? लाइक
नेक्स्ट वाले को हेड बना दिया।
हाँ, बट जो एलिमेंट है जो रिमूव होना चाहिए था उसका नेक्स्ट नल होना चाहिए ना, वो अभी भी नेक्स्ट एलिमेंट को पॉइंट कर रहा है, राइट?
हाँ,
आफ्टर
उसको नेक्स्ट को आप नल कर सकते हो, नहीं भी कर सकते हो। अगर मान लो कि वो वहां पे है वह जैसे का तैसा रखा हुआ, तो उससे कोई प्रॉब्लम नहीं है। उससे क्या प्रॉब्लम होगा आप सोच के देखो।
ओके, हाँ, बिकॉज इट विल बी नॉट फाउंड एनीवेज,
इट विल
अगर
नॉट
हम
बी फाउंड एनीवेयर, वो कभी उसका रेफरेंस कहीं आएगा ही नहीं, है ना?
ओके ओके, गॉट इट।
कोई भी नोड है, उस नोड पे 100 रेफरेंसेस हो सकते हैं, उससे कोई फर्क नहीं पड़ता, लेकिन उसका नेक्स्ट पॉइंटर एक ही होना चाहिए।
गॉट इट, थैंक यू।
कितने दूसरे नोड उसको पॉइंट कर रहे हैं उससे फर्क नहीं पड़ता, वो नोड सिर्फ एक यूनिक नोड को पॉइंट करना चाहिए। तो अगर आप उसको नन करना चाहते हो तो आप कर सकते हो, नहीं करना चाहते हो तो वो भी ठीक है। If you want to check, if you want to write this is empty method, how will we do it?
We need to check the size.
We can check the size, right? So you can
Yeah.
check the size, or is there any other method?
If head is none.
Head is none, you can do.
Yeah. Self.head.
Self.head is none also you can do. If you want, you can return the size also. You can say return self.size is equal to 0. This also you can do. Okay. All of you are clear? Now
Yes.
in this implementation, we wrote one method which was toList, which is converting the stack to a list. So here also we will write one method toList. How can we do this? How can we convert it to a list?
Directly to
How?
list. Return list of.
Simply we can do return list of
That self dot.
list of what?
That value.
List of what?
The stack to list, right?
Think before saying what you are doing right now. How will we convert it to a list? Think.
Yeah.
You have to think.
Stack, no? The stack object.
What?
When we put the object to the class, right? So what is object name?
Everything is in front of you.
Okay.
Guys, if you don't respond, then I feel that you are not
Then
understanding.
I think we have to traverse the entire linked list and
We
store
will
it
have to traverse the linked list node by node and append it to
a
collect all
separate.
the values and put it in a list. There is no other way. Okay. So much discussion we have done on linked list. Why we did so much discussion on linked list? So that these things we will be able to move in a fast way. Okay. We'll put the current pointer on the head and we'll create one elements dictionary list and we'll say while current, okay, we'll say elements dot append
Append of list.
current dot You can append the node also, you can append the data also, because ultimately we are interested in the data only. And we'll say current is equal to current dot next.
If you want to insert the node, then just current, right?
Current you can do, but why do you want to have the node?
No
It
need
is
that.
not needed. Then we will have elements. We'll put here list like this, list of elements. Okay. Then we want to have one
Okay.
method, str method. So str and REPR we have written above, same thing we will copy. Why? Because they are using this self dot to list.
Yeah. But this is another method, self-test.
So what we
You
can
need
do
also.
here is we can simply not use list here, because then it is slightly problematic. We can say self dot to list. Okay. Then it becomes more reusable code, because we have written this we have written this method here. Okay. So we have done this. So what we'll do, we'll take these both things and we will copy it here. We will put it here. Okay. Now it is possible that we might have made some mistakes. So let us go and try it out first. So we'll say reversed. Here also I think we will need reversed. Self dot size. Line number 76. Self dot size minus equal to 1. Okay. So what I want to do now, whatever code we have written earlier, this code, same code I want to run again. Okay. So I'll say my stack is equal to linked list stack. Okay. And if everything is done correctly, then whatever code we have written for list stack, same identical, same thing should run for linked list stack also. Do you guys agree?
Yes.
See, now we are getting this error. See, size. We have not we did not write size method. So we are breaking the abstraction. So we should write one method called size. So what will size return? Will simply return self dot underscore size. So let me go back up. Use a linked list stack. Size is working, push is working, size has become 1. Okay. Now I'm doing 20, 30, 40, 50. So if I run this, it should identically give me the same result. So see, but I'm not getting the same result. I'm getting ulta result. Why ulta result? Why am I getting ulta result? Because someone tell me why I got ulta result. If you guys are following, then you will be able to tell.
Yeah.
Because
Because you
when
head now, our latest element is a head element in the link list.
Okay. So
Whatever.
you see all the code is
आई
working.
थिंक जब वो लिस्ट के अंदर हम लिंक लिस्ट को स्टोर कर रहे हैं ट्रैवर्स करके,
हाँ तो
तब टॉप टू डाउन कर रहे हैं, लेकिन जब प्रिंट कर रहे हैं तो वो रिवर्स प्रिंट कर रहे हैं ना
जब
हम।
हम लोग जब हम लोग लिस्ट से स्टैक यूज कर रहे थे, तो लेफ्ट टू राइट वो चलता है ना, तो राइट साइड में हम अपेंड कर रहे थे, लेकिन लिंक लिस्ट में हम लेफ्ट साइड में अपेंड कर रहे हैं, अगर आप उसको एज ए एरे अगर विजुअलाइज कर रहे हो तो। ठीक है। लिंक लिस्ट के केस में हम लेफ्ट साइड में अपेंड कर रहे हैं, हेड तो लेफ्ट होता है, तो इसीलिए वो जब हम इसको ट्रैवर्स कर रहे हैं, व्हेन वी आर ट्रैवर्सिंग दिस वन, द फर्स्ट एलिमेंट इज द लास्ट एलिमेंट ऑफ दिस स्टैक. So that's why here we don't have to do reversed. When we were doing here, then we had to use reversed. यहाँ पे
Okay.
I did reversed.
लास्ट
यहाँ पे भी reversed होगा. If you did not understand, then try it out on your own. Okay, you see our entire linked list wala code is working fine. If I do my stack, you see it is 2010. Again, I'm popping. It is 20. It is 10. Again, I'm popping. There is no value now. Again, if I pop, you see I'm getting the error that my stack is empty. Is everyone clear, guys, so far?
So while we implemented a linked list, right? Either linked list or list, the topmost element only is going to remove, right, sir, for the stack.
Yes, because
When
that
we
is the
perform.
definition of stack. It does not matter how you are implementing it. If you are calling it a
Okay.
stack, then it will always, you will remove elements from the top.
Okay. So in this case, in the linked list, we use the head method, right? We are inserting element at the beginning for every time. So what is the use to apply the reverse? Because it's a 10, 20 like this, right? 10, 20, 30, 40, 50. Yeah, I understood, sir. When we reverse only the 10 we can replace, right? Now my question is that when we performing the 10, 20, 30, 40 by using the linked list stack approach, so while applying the reverse to only it can work. We can remove the element when we perform the
We are
pop
doing the reverse
operation. It
only
can
for
do.
visualizing. It has nothing to do with popping, removing.
Okay.
We are using this only to visualize. When I'm
Okay.
going
So
to
if this,
listen,
yeah,
listen.
understood. If this case, while inserting element 10, 20, 5 element, right? Then when we performing the pop operation, which element is going to remove from linked list approach? Is it removing the 50 or 10? 50 only,
Or
right?
in this one,
Yeah, this one.
according to you, what should happen?
You should remove 50,
It
but
will remove
ideally,
50.
yeah, correct.
I have visualized it this way because this is how I was drawing it in pen and pencil, one top of the another. This is how a stack is. This is my custom visualization. Like 10 is the first element, after that 20, after that 30, after that 40, after that 50. So when you pop,
Correct.
first 50 will come out, then 40 will come out, then 30 will come out, after that 20, after that 10.
Okay.
What is the doubt or confusion?
No, my doubt is that the stack approach, list approach are behaving the same way or different way while we performing the pop operation.
Everything is same.
Same, no? Okay.
Yes. It
What is the
has to
latest
be.
element?
It, listen, it has to be. There is no question
Mhm.
that stack will behave differently. That is the whole idea, that the outside interface is going to be identically same. That's why I showed you the same code. First I ran it using list, then I ran it using linked list. This is the whole idea, to show you that if you're creating a stack, it will behave the same way. I can use list also, I can use linked list also, I can use a deck also, I can use a queue also. No matter what I use to create this stack, the behavior of the
Okay,
stack will be same.
got it.
Understood? Does anyone have any questions still here? Anyone having any questions still here, guys?
The the private specification is valid, is needed or it's not necessary.
Not able to understand. Please
No,
loud.
private one
Sorry.
underscore, right? When you applied with underscore head underscore size, right? So is it mandatory? If I don't want to worry about the security and can I I
You tell
I
me.
can't use it.
You tell me. According to you, what it should be.
Yeah, this is for we cannot access. This is a private specification. So my question is that
Are you not
could
able
it
to
be
access it? You are able to access it. You will be able to access it.
correct? So we can implement such a way, right? Is there any
I'm
issue?
not able to hear what you are saying. Your voice is very muffled. I'll say my stack is equal to linked list stack. Okay. Then I will say my stack dot push 40. then I will say my stack dot push 50. Now if I come here, if I say my stack dot head, I'm able to access it. Dot data, you see I'm getting 50.
Yeah,
So I'm able to access it. It is a protected variable.
correct.
I, at least in this class itself, I think 5 times I've already said that it is a protected variable. You can access it, but it is a convention that it is not supposed to be accessed. If you want to restrict access, then use double dunder, then use private variable. Even private variable can be accessed.
Okay.
Can be accessed. How?
So, you know,
Using name
dunder.
mangling.
Yeah.
All these things I've taught in a lot of detail.
Mm. Yeah, so this is fine, but my question is that is it mandatory to define the underscore, or can we make it as a public variable? Is it okay for stack approach?
You tell me, according to you, what should it be?
Yeah, my
Is
application
can
is
is it mandate? Do you think it is mandatory based on your Python knowledge?
Mm, I don't think it's just kind of a security purpose. Depends on that application. It depends on the application.
It's not mandatory. Even if you remove it, the code is going to work fine.
Yeah, that's why I'm asking that.
It's not mandatory.
Hmm.
It is a convention. Again, I am telling it's a convention. It's good manners.
Hmm.
It's good manners. It is a gentleman's agreement that if I am putting underscore, then please don't access it. Okay.
Okay.
Someone wants to access it, they can access it. Python is not restricted. Then let us do stack implementation. Let us do some questions on stack now. Okay. After that, we'll move ahead.
Okay.
There is one more thing here which we have to see, which is implementation of stack using a deck. Okay? Implementation of stack using a deck. What is a deck? Deck is a double-ended queue. Now I have not taught you about queue, so this part I'm leaving right now. We will learn about queue. We will learn how to implement a deck, because deck in itself is a data structure. So double-ended queue, we will learn how to implement it. Then we will come back and we will learn about deck. But deck need not be implemented from scratch. Why? Because deck is already there in Python. We can import deck from collections, import deck. See, deck. So for now, you can imagine that deck is nothing but it is a variety of a doubly linked list. Now, what is speciality of a doubly linked list? Can someone tell me? What is the speciality of a doubly linked list? We studied what is the main benefit or main characteristic of a doubly linked list.
And
we can
traverse
make
from both sides.
traverse from the both side, but that is not the speciality. Okay.
speciality of the
Sorry.
double English. Yeah, that is
You
one
can in.
feature. Insert at okay.
I can't hear what you are saying. Insert at beginning, insert at end. Okay. Remove from beginning and remove from end. All these operations can be done in O of 1. This is the main characteristic what we studied about a doubly linked list. We also did one problem in that, if you remember.
Yes.
Okay. So that is only double-ended queue if you use a deck. Okay. So if we create a deck, say for example, I'm saying my deck and I'm calling it deck. Okay. So if you want, you can do my deck dot append 10. I can do this, which means just like a list, we are appending something in a list. Okay. But we can also do my deck dot append left. This is normal appending to the right side. But you see what this is, append left. Append left is, suppose I'm doing 20. So this is appending to left side. Appending on left side. So if you are appending on a left side in a normal list, then that is O of n. But a deck is implemented in such a way that if we append on the left side also, if we append on the left side also, then also it is O of 1. Because behind the scenes, a deck is using a doubly linked list. It is a variety of queue which is using a linked list. You see how all these different data structures are intertwined. Stack, queue, linked list, array, and doubly linked list with tail, without tail. Are you guys able to understand? Please tell me in the chat. How many of you are following?
So deck is similar to same way, right? The double linked list feature speciality.
Yes.
Okay.
My deck. So it is
But
showing me
why I'm
20.
learning this so much? So if all are similar, तो
They are similar. But सबका अपना अपना यूज है ना.
मतलब उसको लिए क्या है के लिए हम किसके लिए यूज करते हैं अभी तक तो यूजेस दिखा रहे हैं जो प्रैक्टिकल में
दिख जाएगा दिख जाएगा. ठीक है. So if we do append, you see 30. जब आप एबीसीडी पढ़ रहे थे स्कूल में एलकेजी में, तो आपको दिख रहा था एबीसीडी का एप्लीकेशन कि आगे चल के आप स्टोरीज पढ़ोगे, नॉवेल्स पढ़ोगे, फिजिक्स केमिस्ट्री पढ़ोगे.
ये तो इसमें तो डिफरेंट एग्जांपल है ना वो
तब नहीं दिख
डिफरेंट था
रहा था
ये
ना. तो पहले हम लोग सीखते हैं कि क्या चीजें हैं, फिर उसका एप्लीकेशन भी आपको समझ में आ जाएगा. एप्लीकेशन समझने के लिए टाइम लगेगा थोड़ा सा. जब आप यूज करोगे ना तब धीरे धीरे वो आएगा. पहले समझिए कि क्या हो रहा है. अगर आप मन में ये बैठा के रखोगे कि जो हम पढ़ रहे हैं वो बेकार ही पढ़ रहे हैं, इसका तो कोई यूज नहीं है, तो फिर वो कोई फायदा नहीं है उसका. यूज होगा, ठीक
तो
है,
अभी
यूज
तक तो
आएगा.
समझ में नहीं आ रहा है क्या यूजेज है क्यों यूज कर
आएगा
रहे हैं इसको
आएगा आएगा आएगा. ठीक है, थोड़ा सा पेशेंस रखिए, पेशेंस रखिए. ठीक है. Do we get interview questions on these data structures? That is the whole point, no Mustafa. इंटरव्यू क्वेश्चंस आते हैं डेटा स्ट्रक्चर्स पे, तभी तो हम लोग कर रहे हैं ना ये सब. ये फेसबुक के इंटरव्यू में पूछा जा चुका है क्वेश्चन मेरे फ्रेंड को. इम्प्लीमेंट स्टैक यूजिंग अ लिंक लिस्ट, मेटा के इंटरव्यू. ठीक है. मैं आपको कोई भी, मैंने आपसे फर्स्ट डे ही कहा था कि मैं आपको ऐसी कोई भी चीज नहीं बताऊंगा जो बेकार की चीज, जो आपके काम नहीं आएगी. ऐसी कोई भी चीज हम लोग डिस्कस नहीं करेंगे क्योंकि हमारे पास टाइम बहुत कम है. 6 से 8 महीने लगते हैं इस चीज को पढ़ने के लिए. बेसिक इंट्रोडक्शन के लिए हम लोग 3 महीने के अंदर पढ़ रहे हैं इसको. ठीक है. तो जो बेसिक चीजें हैं, जो 100% आपको आनी चाहिए, जो अंडरस्टैंडिंग, जो लॉजिक बिल्डिंग, ठीक है, तो हम लोग वो उतना पढ़ रहे हैं. इसके अलावा और भी बहुत कुछ है, लेकिन पहले इंट्रोडक्शन, पहले बेसिक ये आपको आ जाएगा, इसके बाद लेवल 2, फिर लेवल 3 से। ठीक है। इसका लॉजिक को समझिए, लॉजिक क्या चल रहा है ना, अपना माइंड मसल को ट्रेन करना है। आई डोंट नो कौन मेरे से पूछ रहा था कि इसका एप्लीकेशन क्या है। आपको पहले अपना माइंड को ट्रेन करना है लॉजिकली सोचने के लिए। अगर आप ये सोचते बैठोगे कि हम पढ़ रहे हैं, इसका कोई यूज ही नहीं है, कोई यूज ही नहीं है, कब यूज होगा, कब यूज होगा, तो कोई फायदा नहीं है। वैसे जब हम लोग कोई चीज पढ़ते हैं तो हम लोग ये अज्यूम करके चलते हैं कि आगे इसका काम आएगा, पहले उसको समझ तो लो, है ना। सिंगली लिंक लिस्ट अलग है, डबली लिंक लिस्ट अलग है, डेक अलग है, स्टैक अलग है, क्यू अलग, सब अलग है, इंटरट्वाइंड है, कॉन्सेप्ट्स मिलते जुलते, बट है सारे अलग, सबका एप्लीकेशन अलग है। और मैं एग्जांपल देके बहुत बार समझाया भी हूँ कि कैसे कैसे डिफरेंट है सारी चीज। ठीक है। तो deck, if you want to learn more about deck, so this is a basic functionality of a deck, that you can append from the right, you can append from the left, you can also pop. So normally when we do pop in a list, it will remove the last element. Okay, you see the last element got removed, 30 was the last element, it got removed. This is normal behavior like a list, but a deck will enable us to do one extra method, which is pop left. Okay, if we do pop left, this operation in a list, this operation in a list is O of n, but in a deck, whenever I say a deck, try to imagine a doubly linked list. So in a deck, it is O of 1. This is the major benefit of a doubly linked list or a deck, double-ended queue. Now queue you have not learned right now. Queue we will discuss a little bit later, but for now just think that a deck will allow you 4 operations: insert in beginning, insert in the end, remove from the beginning, remove from the end. All these 4 operations in O of 1 operation, O of 1 time complexity. Okay, iska explanation I have given in the linked list wala lecture. Detailed explanation I have given. We have implemented it also. Now we can go here and you can read a little bit about deck. Deck in Python. The official documentation pe you can go and you can check here. Okay, you can see. It returns a deck object initialized left to right using append. Decks are generalization of stack and queues. Deck is used for stack and queue. So now can someone explain to me why deck is a generalization of stack and queue? This is my question to you. This can be an interview question also. Why deck is a generalization of stack and queue? Because it works in both directions. Vikas is saying absolutely correct. Okay. I have not taught about queue right now. Okay, but I'll tell that stack. We push, we add and remove elements from the same end, and in a queue we add from one end and remove from another end. Okay, so in a stack you need one end, in that end only you are adding or removing, but in a queue you are adding from one end and removing from the other end. So if we are able to create a data structure this in which we can add and remove elements from both the sides, then that thing can work as a stack also, it can work as a queue also. That's why deck is a generalization of stack and queue, or we can say that deck can be used as a stack and as, or normally what will happen, we will use deck as a queue. Okay, because we are using list as a stack, but you can use deck also as a stack, deck also as a queue, but normally we'll use deck as a queue. So going forward, when we learn about queue, you will see by default we'll use deck. When we are learning about graphs and trees, there also whenever we have to implement a queue, by default we will use a queue. We will not do all of this whole defining thing. This we will not every time implement from scratch. We will use a deck directly. Okay.
So can we
There
also
any
say that like doubly linked list also a generalization of second queue?
Doubly linked list is not a generalization of stack and queue.
But
Doubly
we can
linked list is a
implement.
different. Doubly linked list can be used as a stack and queue. Deck is a type of doubly linked list.
Okay.
okay.
It has some more features which we cannot discuss, but it is a type of doubly linked list. You can imagine in your mind that whenever we talk about deck, it is a doubly linked list. Actually, it is a doubly linked list only, but the Python implementation, Python में जो deck module है ना, it is slightly more optimized. This deck. Okay. When I say deck, okay, there are two connotations to deck. When I say deck, it is a doubly ended queue. Okay, so there are two connotations. One is a uh, general deck, and one is a Python implementation of deck. A Python module, deck, Python module. Okay, when I say Python module, I mean the collections library ke andar there is a deck which Python they have created. Both are doubly linked list only, but in the Python module, the creators have added some extra things. It is some block based memory. There are arrays also, arrays and linked list ka mix karke it has become a data structure, which we don't have to study. Which we don't have to study. But generally, a deck is nothing but it is a doubly linked list only. Okay. So when I say deck, sometimes I'm referring to this Python module. Other times when I say deck, I mean a general deck concept.
So use case by using DQ, right? So in this case, which one do I need to prepare?
I
If
can't
it is
hear you.
a
Can you
any
be a little?
problem?
Can't hear you. Can you be a little louder, please?
Oh, no. We have the very limited use case in DQ, deck operation, right? Only per the speciality of doubly linked list. If we get any problem, so can we go ahead with deck queue or doubly linked list? So the for those operation only.
Deck is implemented in Python. You can directly go here and you can say from collections, import uh,
Yeah.
deck, and you can do your work. Okay,
Okay. It is faster than doubly linked list.
it's not like that. It's not like that. Okay,
Okay.
asymptotically both are O of one only. But if they are asking you to implement a deck, then you have to implement it from scratch. But if you are solving some problem in which you need a queue, then we will not write queue again from scratch. We will use a ready-made queue or a ready-made deck.
Mhm.
So ready-made deck, if you want, we can use from the collections module.
Okay. Okay. Is it also the abstract kind of data type
Yes,
or?
yes, yes.
Yes. Got it.
Okay, queue we have not discussed. I will discuss in some time. But now, if you know this much about a deck, if you know this much about deck, that a deck can be used to append and pop from both ends, then we can very easily create a stack using a deck module also. How can we do that? Let us do it and then we will jump to the questions. I will say from. It will be same as list. Okay. It will be same as list. Only few changes we'll have to make. Okay. Instead of list stack, I will make it a deck stack. Okay. Instead of list here, I will say this is a deck. Okay. Then when we are pushing, it is going to be the same because in a deck also we can append. Deck also is having an append method. If we want empty is empty, we can use this same method. There is no problem. Self.size. Okay. If you want to push, append is fine. If you want to do pop, okay, then also we can use the pop method. There is no problem. And if you want to do top also, there is no problem. You see why I told you that Python implementation is little bit different, because if you see my deck, it is able to give me this index. You see, in a normal doubly linked list, you cannot do last index like this. But Python implementation is giving me this behavior of a list. It is actually a doubly linked list, but it is behaving like an array also. So how that is happening is beyond our discussion. But just keep in mind that it is a data structure in which both ends we are able to insert or append. So this is very easily we have copied the stack implementation using a list, and we have made it a stack implementation using deck. Now we can run this and we can create my stack is equal to deck stack. Let me go back, and in the same code I will make the changes. And if all our code is running, that means our implementation is correct. So I'll comment this out and I will say my stack is equal to deck stack. Okay. Now see, our code is working. 20 we have pushed, 30, 40, 50 we have pushed. Then you see 10, 20, 30, 40, 50. If we do top, we are getting 50. If we do pop top, we are getting 40. If we pop 40. If we again do, we are getting 30, 20. Now we are having only one element is empty, is false. Again, if we are doing one more, now if we do, my stack is empty. And if we do is empty, now it is giving me true. Again, if I do pop, then it will give me error. The stack is empty. Guys, all of you have understood? Anyone having any confusion or doubt in this? What we are doing, why we are doing?
No, we are clear. We have to practice.
We have what we are doing is we have learned different data structures. Every data structure is having some ADT. It is having some kind of model. It is having some kind of operations, its own behavior, its own specialities. It is having its own pros, its own cons. For example, list, linked list, stack, queue. Now individually when we have studied them, now a very common way to evaluate your understanding is that using one can you achieve the other. If you know array, can you create a linked list using that? If you know stack, can you, if you know stack, if you know linked list, can you use a linked list to achieve a stack? If you know stack and if you know queue, can you use a stack to create a queue? Can you use a queue to create a stack? It is testing your logical thinking of how well you are understanding these things. Okay. Now in real life you will say that, sir, do we have to do all this? No, you don't have to do all this, because all of this problem is already solved. Deck is already there in Python. What is the need to write all this code? So writing all this code is for understanding what is happening. Are you getting it? Is to understand how deck is working, the inner working of things. Can we move ahead, guys? Do you guys want a break? We'll take 5 minutes break.
We will have a break and continue, sir.
We'll take a break till 6:35. Then we will be back. Okay.
Yeah. We understood the concept, but we will practice from our.
You have to spend time on it.
We
You have
need
to
to spend
spend
time
time
on.
on it. You have to digest, spend time on it. Okay.
Yes, sir. We have very limited time, sir.
You don't have
So
limited time. For whatever we have taught till now, you don't have you have sufficient time. I'm teaching one topic and then you are having 5 days to understand it. It's more than sufficient.
yeah, sir.
In the interview, do they specifically ask to implement queue using space? Yes. Lucky ji, yes. You can see lead code questions.
So yeah, won't it be the toughest problem from stack or queue, right? It's kind of this defined format of the problem.
Stack using queue.
What
You can see implement stack using queue. Implement a
Hmm.
last in first out LIFO stack using two queues. Okay. Similarly, you will have
Oh,
queue using stack. You
yeah,
can say
linked list queue.
double-ended queue.
Double. Yeah.
Sorry, circular queue. You can see design circular queue, order queue, circular. These things are questions. These are commonly asked questions. Okay. Chalo, we'll take a break and we'll be back after 5 minutes.
Yeah, sure.
Hello, Ram sir, are you there?
Yes, sir. Tell me.
I have a one doubt, not from this classes.
Tell me.
Uh, while suppose I'm preparing the resume, right? So
Uh,
what things I need to keep the in terms of like DSA and all?
for DSA in your resume,
No,
Ball.
can you repeat your question, please?
my question is suppose I'm preparing the resume, right, for the next job and all. So
Okay.
shall I put that DSA part like
No,
the
no,
kind
no,
of
no, no.
no, not needed, right?
Not needed.
No,
DSA is
that's
not
fine.
needed.
Mm. Because
If you are having
some
if you are having some high rating on some competitive programming, CP, or some very high score on lead code, then you can put those things, but that is not at all needed.
oh, okay, okay. So,
DSA from interview perspective is only for screening.
mm-hmm.
They will use DSA to check your problem solving capability.
Yeah, I know this thing, but yeah, the thing is I wanted to know whether I have to add
No,
these
no,
things
no, no.
because some other organization, like it's a whatever the product-based company, they will ask a DSA part, right?
They will ask you DSA, but you don't have to put it in your resume.
That's
Resume
fine.
is for the work that you do, that you have
Mm-hmm.
done. DSA is
Okay,
not work. DSA is your academic knowledge.
correct.
Okay.
Okay,
If you are very active in competitive programming, if you have won some contest, then those things you can put it. But general DSA knowledge is not needed.
okay, okay, got it. Thank you. One more doubt is here. Like, suppose I am applying in the product-based company, I'm having the more than experience. Suppose I'm having the experience, right? So, hello.
Yes, yes, tell me.
Suppose I'm having 10 years of experience and all, right? So, maybe in the product-based company, they will ask also this one data. This one,
Data structure, DSA.
no, data structure will ask definitely, but another thing's also right. There is some I forget the name.
In
Um,
product based companies, in what role you are applying? Software engineer.
hmm.
Then they will ask. Not all the companies, very few companies will ask.
Suppose as of now I am the senior data scientist, right? I will apply definitely for the AI tech stack, right?
Uh, uh, uh. So
So they will.
top product based companies will ask you DSA.
Mhm.
Not all the companies, but every company will have some kind of logical thinking around. Some
Mhm.
companies will ask puzzles. Some companies will ask SQL. Some
Mhm.
companies can give you case studies. Some
Mhm.
US based companies like Meta, Amazon, Facebook, Uber, PayPal, Flipkart, these questions, these companies, they will ask DSA, but not all the
Mhm.
companies.
That's what I'm saying. These top product company.
They will ask, yes.
There is another things also, right? Data structure. One more is I forgot the name exactly. Uh,
Depending on company, some they will have you screening for DSA. Then you can have some domain knowledge round. Then you can have some system design round.
system design, system design.
Depending on your seniority, you can have a machine learning design, system design, low level design, high level design.
Uh,
This type of rounds will be there.
in the system design, like what needs to like I'll have to cover. Supposing if I'm going to attend the interview, Walmart or some other organization.
So see, system design is based on the work that you have done. System design, it is difficult to prepare separately
But
because
there is some topics also, right? So like
topics are
solid.
there. Topics are there. For example,
Uh, hmm.
designing how do you build a server, how do you build a load balancer, how do you build a recommendation system, how do you build large scale
Solid
for
principle.
solid principle, database
Mm,
principles,
mm,
these things, where you will use what type of database, what type of scaling you will do, how you will handle errors, fault tolerance, uh, CDNs, these kind of
mm,
things. They will different types of proxies.
mm.
These type of things they will ask you. So usually when you are working as a senior software engineer, you already have exposure to do these things. So we will do, but we'll also prepare from interview perspective, like how
Yeah,
will
that's why I'm
someone
saying
go through
interview purpose.
interview perspective. It's a different discussion, we will have it. But when a
Mm,
problem is given, you understand the scope, so those interviews are most discussion type of interviews, where you will also
mm,
ask some question, they will help you. Together you will somehow uh, arrive at some situation. For example, they will ask you how to design a YouTube
correct.
homepage. How
Mm,
do you build a recommendation system for YouTube? So if I'm asking
mm,
you this question, then you simply cannot start building a recommendation system for YouTube. You will ask me
correct.
more questions like how,
Oh,
what is expectation, how do we do, right? uh,
it's
that type of questions you will ask, then they will also give some answers, then you will kind of give some approach. So it is a different type of interview. It is not like the lead code style interview. You will have a
okay.
whiteboard. In that whiteboard you will put your assumptions, then you will draw, like that it will go. So it's a completely different type of interview. And usually if you're a beginner, then these interviews will not be there. It is only for much experienced people. They will not
Okay.
ask you if you are 1 or 2 or 3 years experience, then usually system design round will not be there. If you are from AI,
Just
then you will have a machine learning round, not system design round.
okay, okay. Then as yeah, I have a total more than 10 years of experience in IT industry.
Then
If
then you
talk
can
about
expect.
then if talk about the data science, yes, 6+ years.
Then you can expect a system design.
That's why I'm saying I'll have
Yeah.
to look into this also, right?
Yes, yes, yes.
Okay. Thank you. I got yours.
Yeah. Let us start.
Will you be planning to take system design, sir?
No, system design is not. System design is
Later.
it's not a part of this course. It's a different field. It's not related to what we are learning. It's a different subject.
Okay, yeah, I understood. It is different only. So are you planning to take it up in future or any planning?
No, no, not right now. There is no plan for system design, because system design is not useful for most of the people. It is useful only for a very small set of people.
Yeah, yeah. It has more than 10 years, they would
Not more
expect
than
from
10 years,
market.
but 4 or 5 years of experience. Then only system design is useful. Otherwise, it is, see what we are learning, it is useful for everyone. Everyone should know these things. Okay. What we are learning right now, but system design is different. Chalo, let us move ahead and let us solve 2 problems. Then we will close today's discussion. Okay. We'll close by 7. We'll try to close it by 7:15. So what we will do, let us do one question, which is balanced parenthesis. It's a basic question we are doing. Now, when we are trying to solve any question, and if we want to use a stack in that question, then we don't have to create stack again from scratch, like how we have done in our class. We don't have to do it again from scratch. We will simply use what? What can we use? If we want to use a stack, implement a stack, then what can we use?
DQ.
We
Will
can
this,
use, it's not DQ, it's a deck.
Okay, sir.
DQ is different. When we learn about Q, then I will tell you DQ is different and deck is different. Spelling
Okay,
is
sir.
little bit similar.
Okay.
So we can, if we want to use for problem solving, when if suppose you are reading a question and it comes to your mind that this question is a stack question. Okay. So you can use a deck or you can use a list. Simple list also you can use. Okay. But while explaining, you will say that we are using a stack. The concept will be of a stack. But you can, while writing the code, you can use a list. All of you are clear, guys? So just let us try to solve. Let us try to solve this question. This question is valid parenthesis. So can someone please read the question and then explain it back to me? What does the question say?
Your screen is not visible to us.
Screen is not visible. Oh, sorry. Sorry, I forgot. This is the question. Try to read this question. And then tell me what is the approach that you are thinking what we should do here.
Again, the screen is wiped away.
Screen is not.
Yeah, maybe it's dropping.
Can someone tell me an approach? The question talks about valid parenthesis. Did you guys read the question?
Yes, sir.
Did you understand the question?
Yeah,
Can
it
someone
is relevant.
just
Yeah,
explain the question to me?
yeah, they have given the input string should be the below three conditions. Okay, the first condition, the open brackets must be closed by the same type of the brackets. For example, so when we pass the string input string, the bracket should be the similar. For example, so curly braces, it should be open and closed, and the square bracket it should be open and closed. The input element should be like this, and then point number two is the open brackets must be closed in the correct orders. Yeah, maybe open braces and close braces properly. It should not be interchange. The order should be correctly. The point number three is every closed bracket has a corresponding open bracket of the same type. It should not be, for example, if we have the curly braces, we should not close with the square bracket.
Correct.
So, yeah, it should be
Correct.
the similar. Yes.
Correct. So how can we solve it? Can you relate this to the concept of stack?
Yes.
Tell me the approach. Someone tell me an approach. How this is linked to the concept of stack. In stack, what we are doing?
Like in stack, like whatever the first condition will be exactly the concept of the stack. Like we cannot interchange the odds of the bracket insert and delete, because we can only follow the order. If the open is there, then the closed one will only be popped.
Okay.
I think we can insert any character given on this
Let us
one
take
by
some
one.
example. Let us take one example. Suppose this is the example. Okay. How will you check if this is valid or not? Guys, please mute yourself. Okay. So if this is given to you, what is the first character? This is the first character. Okay. If I look at this character, can you tell me that if this is valid or not? So far, because it is the opening bracket,
It's not valid.
Yes.
that's why we don't. That's why we don't know whether it is valid or not.
Yeah.
Because there is some more character which is yet to come. Now, second character is this. Okay. If I'm getting this character, then can we say anything about valid or invalid? We are
It's
saying that it is valid.
valid.
How are we saying it is valid? Because we got a closing bracket. If we get a closing bracket, then we need to check the last bracket. Okay, and what we need to check? The last bracket should be open bracket. First condition is that last bracket should be open bracket. And the second condition is the last bracket should be the correct open bracket. It should be open and it should be correct. What is the meaning of correct? The meaning of correct is that if this is the closing, then opening can be this only. If suppose I'm getting like this, then can we say it is invalid?
Yes, it is invalid.
Because this is a closing bracket. So our condition is that we get a closing bracket. When we are getting the closing bracket, then we need to check the last bracket. So we'll check this bracket. Now this bracket should be open bracket. Fine, it is open bracket, but it is not the correct open bracket. It should have been this. Sorry, it should have been this one. Correct? No? Are you guys following what I'm saying?
So that means at a high level, whatever the order which we are following for the opening braces or bracket, we have to follow the reverse order of the closing bracket, right?
Yes, but in order to check, that is high level. But if you are doing a running check, then what we can say? We can say for character in S. Okay. If the character, I'm writing pseudocode.
Sir, I didn't get a point. You're telling that the last bracket should be a closing, should be open bracket.
Yes.
But I feel it should be a closing bracket. Why? I mean,
Wait.
Can you explain once question and
I'm the first bullet point you put. I'm saying
Which one?
The first bullet point. It doesn't
This
go
one?
with my logic here.
Okay. Tell me what is confusing you?
The last bracket should be open bracket. But if you see the logic here, if the string is having a C-section bracket, the first character is bracket.
The first character is this one. Okay.
Yeah. The last you're telling is open bracket. It should be a closed bracket, right?
Okay. What I mean to say is that suppose this is the bracket. This is the open bracket.
The
पहला जो bracket आया ये open bracket.
Yes.
Okay. If it is an open bracket, then we cannot make any judgment. If it is open bracket till now, at this point of time, we cannot make any judgment whether this is correct or wrong.
So you're telling about the first character, but here the first bullet point is saying the last bracket should be an open bracket.
Listen. Maybe the
The
way I have
last
written it,
bracket, does it mean previous one, right?
previous. You can say previous.
Followed by the open
Okay,
bracket.
okay, yeah. I mean, now it's
Previous.
clear. Yeah, now it's clear.
Okay.
Yeah, that's
So
right.
I got one character. This character is a opening bracket.
Yeah,
if it is
yeah.
an opening bracket, I cannot take any judgment.
Hmm.
Now the next character is this one. So
Yeah,
if
that
we
makes
get a
sense, yeah.
closing bracket, then
Right.
what we have to check?
We have
We
to
should
see
check.
the first or the previous bracket is the open bracket.
The previous bracket should be open and it should be the correct type of the open.
Correct, exactly.
It could have been this, then it would have been wrong.
Yeah, right. Yeah.
Correct. So why it is concept of stack? Because we will always check the last value, which means the top value. That's why it is a concept of stack is coming into the use here.
Okay, fine.
Somebody was asking what is the use? This is the use. Okay, one application to check valid parenthesis. Now you see, we'll do for character in S. I'm writing pseudo code here. Okay, if the character is closing, I will write here if the character is opening, then we cannot. Priyanka ji, पूछिए. Then we cannot.
Sir, maybe it's a very silly point, but ये association कैसे मतलब human eyes can understand this is closing and
बना देंगे ना एसोसिएशन बनाना है आपको,
that's
बना
it,
देते हैं.
okay.
एसोसिएशन कैसे बनेगा? एसोसिएशन में
can-
यहाँ बना देता हूँ कि कौन किसका भाई है. ठीक है,
हाँ
तो अगर ये मेरा क्लोजिंग है तो इसके करस्पॉन्डिंग जो मुझे ओपनिंग चाहिए वो ये चाहिए. ओके, ये बना देंगे, इसमें क्या बड़ी बात. ये एक ओपनिंग है, दिस इज अनदर क्लोजिंग. I was showing you the logic implementation we can do. This is the closing. Okay, and this is the opening. Okay, now what we can check for characteriness. If the character is opening, then we can't judge. If the character is closing, okay, then check the previous character. Okay, then check the previous character. If previous character, what should be the previous character?
Should be opening.
Previous character should be equal to association of character, because this character is a closing character.
Yeah, so opening of association character.
Opening of the so previous character should be the opening of the association character. Are you getting the point? Pseudocode mental model is clear. Forget about the code. Code we will write. Did you guys understand? Now here there are other things. If the previous character is equal to the association character, then what you will do? And if the previous character is not equal to the association character, then what you will do?
Return saying it's invalid.
We will create a stack. We will create a stack. Okay. Then we will start checking for every character in string. If the character is opening, then we will simply append it to the stack.
Yeah.
We will add it to the stack. For example, we were having, what was the example we were doing? I'm trying not to give you the solution, okay? I'm trying to not give you the solution. Okay, so we will create one stack. This is my stack. Okay, what is my first character? My first character is this. Okay, it is an opening bracket, so I will just put it in my stack. Fine. This line is clear. Then I will go to the next character. When I'm going to the next character, if the character is closing, then check the previous character. Check previous character means what? Stack dot pop. Are you guys following? Yes or no?
Yes.
Stack dot pop. Stack dot pop should be equal to the association of character. Association of character of what? This. So what is my character? Character in consideration is this character. Correct? We are talking about this character. This is a closing character. If it is a closing character, we'll go and check for this value in my association and I will get this value. Now this value and this value are same. If they are same, then what we should do? It is a valid case. So I will just remove from my stack. Remove from my stack means I will delete this value also from this stack. I don't want anything. Which means till here my job is done. My stack is empty. Till here my job is done because till here it is a valid. Till here it is a valid string. Now comes this part. So again I'm getting this string. So I'll put it here. And this is a opening character. So opening character means I will add it to the stack. Opening character means I will append it to the stack. That's what we have done. I will go to the next character. Next character is what? Next character is this. Are you guys following? We are going to this character. This character is what? It is closing. Character is closing. If it is closing, then we have to check the previous character. What is the previous character? This one. What are we looking for? We are looking for the same one. So if we are getting what we want, then we will remove this. Now again, our stack is empty. Our stack is empty means till here everything is valid. Again, we will come to this character. This character we will add it because it is opening. Okay. Then we'll go to the next character, this one. We have come to this. Now this is the closing character. If it is a closing character, then what we have to do? We have to check the previous character. Previous character is this. What are we looking for? We are looking for this. So both of them are same. So if they are same, then I will delete it. So now what has happened? My string is empty. All the characters I have seen and my stack is also empty. That means the string that I had, that was a valid string. And actually it was a valid string. Did you guys understand? Or one more time?
समझ में नहीं आया, क्वेश्चन भी नहीं समझ में आया.
क्वेश्चन कैसे नहीं समझ में आया यार? 5 मिनट में दिया क्वेश्चन पढ़ने के लिए. अगर क्वेश्चन नहीं समझ में आया तो हम लोग सोल्यूशन तक पहुंचे कैसे? पहले ही बताना चाहिए कि क्वेश्चन नहीं समझ में आया. How many of you did not understand the problem? Guys, tell me in the chat. Those of you who have understood, write yes. Those who did not understand, write no.
We understood, sir.
नवनीत भाई को समझ में नहीं आया. ठीक है.
Sir,
I will explain one more time. Don't worry. I will explain one more time.
So 1 second, sir. I mean, you have written the line that check the previous character, then stack.pop. Stack.pop will take the last element in the character.
Last element.
Yeah, so it doesn't correlate, no, sir. We need to see previous character. So
previous character will be where? In stack only, no?
Yeah, so stack, say if we go in a live example, we are starting with a opening bracket. The next character is a closing bracket of C section.
You want to say you will do stack.peak?
Yeah, that's what I feel. I'm just confirming from him.
Okay.
Okay.
Stack.peak.
Because if you're starting with a starting character, the logic and the beginning itself is
we will handle. We will handle.
The first character
will handle.
Yeah,
we will handle edge cases. Stack is empty, then what? We'll handle the edge cases.
Yeah.
High level logic, did you understand?
Yeah, but in the first character itself, we are not getting previous character, sir.
So if the first character is opening, if the first character itself is closing, suppose, if it is like this, if first character is closing, then is there any way in which this can be valid?
No, it won't be valid.
So if the first character is closing, okay, then we'll check the previous character. If the previous character is not there, then we'll return false. If it is not equal, then we will return false.
I understand. Yeah.
That it is invalid.
Yeah.
Okay. See, what is the high level logic? High level logic is that I will take a bracket. Okay. If the bracket is opening bracket, then I will not do anything. But if the bracket is closing bracket, then I will check the previous element. The previous element should be an open bracket of the correct type. If it is of the correct type, then I will delete it. It is correct, I will delete it. Okay. If it is not correct, that means it is invalid. Any point, if I find a closing bracket with unsupported opening bracket, there itself I will terminate the code and I will say false. Does this logic make sense? I will explain it one more time. Wait.
So not audible.
Just give me 1 second. Okay. See, this is my string. Let me write it properly. Which question we are doing?
20.
Question number 20, valid parenthesis. नवनीत भाई ध्यान से सुनिए, ठीक है? बात मैं स्टार्ट से बताऊं.
Yes.
ठीक है? हम लोग सॉल्व कर रहे हैं क्वेश्चन नंबर 20. थोड़ा सा ध्यान देना पड़ेगा नवनीत भाई, ठीक है? We are doing lead code 20. Valid parenthesis. I've told multiple times, if you have not understood the problem, don't move ahead. It's a very bad habit. We have been given a string. The string is like this. Close, close, open, open. Okay. We have to decide whether this is a valid parenthesis or not. So is this a valid parenthesis? नवनीत बताइए, ये valid है कि नहीं? Valid parenthesis का मतलब समझते हैं?
नहीं.
Valid parenthesis मतलब ब्रैकेट सही ऑर्डर में है. जैसे ये ओपनिंग, ये क्लोजिंग, ये वैलिड है, ये भी वैलिड है, ये भी वैलिड है, ये करेक्ट ब्रैकेट्स है. लेकिन मैं अगर ऐसे बना दूं, ऐसे और फिर ऐसे और फिर ऐसे कर दूं और ऐसे कर दूं और फिर ऐसे कर दूं, तो ये वैलिड है?
वैलिड नहीं है.
ये वैलिड नहीं है. क्यों वैलिड नहीं है? क्योंकि ये यहाँ पे ओपन हुआ और ये यहाँ पे ये वाला क्लोज हुआ, ये क्लोज नहीं होना चाहिए था. ठीक है? हाउ विल इट बिकम वैलिड? इफ आई मूव दिस हियर, if I move this here and if I move this here, then it becomes valid.
Right.
Correct? So this is a valid parenthesis. Okay? So how will we decide? What is the code to, what is the algorithm to decide? आप पूछ रहे थे ना कि क्या यूज है, क्या यूज है. ये इसका यूज है. देखिए वैलिड पैरेंथेसिस में इसका यूज है. तो हम लोग एक एग्जांपल लेते हैं, सूडो कोड, उसका ड्राई रन करते हैं. This is, I hope you guys are able to understand my handwriting. Okay, so what we will do, we will create one stack. Create one stack. This is how I am creating a stack.
इसमें स्टैक की जगह पे लिस्ट ले सकते हैं या नहीं?
ले सकते हैं, जो मर्जी आप लो, स्टैक बनाओ। अब स्टैक कैसे बनाओगे वो आपका प्रॉब्लम है, ठीक है? स्टैक बनाना है, ठीक है? स्टैक बनाने के लिए क्या करेंगे? विल टेक दिस एलिमेंट, ओके, और इस एलिमेंट को हम लोग स्टैक में डाल देंगे। क्यों स्टैक में डाल देंगे? ओपनिंग ब्रैकेट, ओके, इफ ओपनिंग ब्रैकेट, if opening bracket, then append to stack, or we'll say not append, we'll push to stack. Okay, because if it is opening, then we cannot decide. Then what we will do, we'll take a closing bracket. We'll go to the next character. This is the next character. This is a closing bracket. If closing bracket, if closing, then we have to check. What we have to check? Check previous bracket. Check previous bracket. What is the previous bracket? This is my previous bracket. This is my previous bracket. Are they matching? Are they matching? Matching or not? Yes or no?
Yes.
Matching. So if it is matching, then I will remove this from this stack, and this is also good. Okay. Then what we'll do? We'll go to the next character. This is the opening bracket. Opening bracket means I cannot do anything. I will put it in this stack. Then I will go to the next bracket. I will come here. Okay. Now, are they matching? If it is closing bracket, then I will check the previous element. Previous element is this. Are they matching? Guys, yes or no?
Yes.
They are matching. So I will remove this from this stack. Okay. So I will write here pseudocode, check previous bracket. If matching, remove from stack. Else not matching, then return false. Okay, very high level logic. Then what we will do, again we'll go to this character. It is opening bracket. Opening bracket means push to stack. Then we'll go to the next character. This is the closing bracket. Okay, closing bracket, and if it is closing bracket, then we'll check the previous bracket. Both are matching. Both are matching. Then I will delete it. Okay. Now what is happening? After doing all of this, if stack is empty, if stack is empty means all the brackets got matched with some other bracket. If it is stack is empty, then we will return true. Else false. Are you able to relate why we are using stack? Let us take another example. Let us take another example. We'll take this example. Opening, 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 again opening, then closing, 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 and closing. Suppose this is the bracket. Is this valid? Valid or invalid?
Invalid.
This is invalid. So is our code, is our algorithm working or not? That we will check. Okay, we'll have to take a bigger stack. So let me take a bigger stack. Okay, we'll take the first character. This is opening bracket. What we will do?
Push.
Opening bracket, what we will do? Someone please respond. If it is opening bracket, then what to do?
Sir, push it in the stack.
Push it in the stack. इसको stack में डाल देंगे. Then we'll go to the next character. What is this? This is opening bracket. What to do? Put it in the stack. Again, we are coming to the open. Sorry. Again, we are having opening bracket. What to do? Push it in the stack. Again, we are bringing one more time. What is this? Opening bracket. What to do? Push it in the stack. Which means till here, we cannot make any judgment whether everything is correct or not. Now we will make the judgment. This is bracket. Now this is a closing bracket. If it is a closing bracket, then what we will check? We'll check with the top of the stack. Top of the stack is what? Is it
Closing.
correct type or incorrect type?
Correct.
Correct type. So I will delete this. Okay, what was the structure that we started with? We started with this, 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 then this, and this. This was our string, correct? So this is opening nothing, this is opening nothing, this is opening nothing, this is opening nothing. Now we came to this character and we found that this is a match. So if this is a match, can we delete this? If something is matched, we can remove it. We can remove it. It does not make any difference. Now what we will do? Now we'll go to the next character. We'll go to this character. Now here what I should find? What I should find here in order for this to be valid? I should find this one. Yes or no? Because what is the last character? Last character is this one. Guys, yes or no?
Yes.
But when we come here, you see, we go to the next character, we come here. We are getting this opening bracket of square type. And if we check our stack, what are we finding? Are we finding the wrong type?
Yes.
So if it is wrong type, then what happens? This is
invalid.
Will return false. Did you understand?
Yes.
And why stack is being used? Because we are always tracking the last element that was seen. Should I do one more? One more try run.
Yes, go ahead.
नवनीत समझ में आया आपको?
आ गया।
आ गया ना? चलिए तो अब हम लोग कैमरा बंद था क्या इतने देर से? इसका कोड लिखा है हम लोग. शुड वी राइट द कोड?
Yes, sir.
Yes, sir.
So what is the code? What we will do here? First we will create a stack. How will the stack look like? We'll just create a stack. I told you that for creating a stack, we'll simply use a list. You can use a deck also. Then we'll create a mapping. Okay. So we'll create a mapping or association, whatever you want to call it. And we will keep track of which closing bracket corresponds to which opening bracket. Okay. So this is one. And in the question, it is told that there will be only 3 types of brackets. Okay. And we will have what? Closing bracket. This will be opening bracket. This will be opening bracket. Okay. Now we'll come here and we'll say for character in S. For character in S. What we have to check? If S is closing character. How to check if it is a closing character? If it is a closing character, then it will be present in mapping. If S in mapping. Which means if S is a closing character. If S is a closing character, then what we have to do? if S is equal to what we have to check with? You have to check if closing character, then you have to check if stack -1, which is the last element, should be equal to the correct opening type. So what is the correct opening type? Correct opening type is given by our mapping of character. If stack of -1 is not equal to, we can say if it is not equal to, then we can return false. This means what? The closing doesn't match the previous character. There is one more edge case here, that if there is no stack, which means the first character itself is closing. The first character is closing. So there is no need to write it in 2 lines. I can simply write it in 1 line. I will say if not stack and. Did you guys understand this line? Okay. Else means what? The brackets are matching. If they are matching, then what we will do? Stack.pop will remove the correct opening bracket from the stack. Okay. If S in mapping, if S is not in mapping, if S is opening character, then what to do? We'll say stack.append character. We will add to the stack. We will add the opening character to the stack. Okay. In the end, if the stack is empty, then the string is valid. So we'll simply return length of stack equal to 0. If we have not made any mistake, then this should work. So we have made some mistake. What is the mistake?
If character mapping.
कहाँ पे गलती की है?
Line number 14.
14.
Line
Okay.
number
14.
14.
If S in
The
mapping.
S should not be in the mapping. S is the whole string. It should be character.
Character in mapping. Thank you, yaar. Thank you. अभी भी नहीं चला, क्या मिस्टेक कर दिया? Character in S, character in mapping. If not stack, यहाँ पे और होगा ना, और होगा. If not stack or both the cases we have to return false. चल गया. It is working. Okay. Did all of you understand this? Now you can do a dry run where the stack is having some characters. Okay. You can do a dry run. So let me copy paste this code. Okay, this is the pseudocode. Suppose you are having a string like this. Okay, then what will happen in the end? We'll take one stack Okay, and you will go to this element. It is a open bracket, so you will put it in the open bracket. Then I will go to this element. Guys, are you following? I'll go to this element. This element is open bracket, so I'll put it in the open bracket. Then I will go to this element. This is also open bracket, so I'll put it one open bracket. Then I'll go to this one. It's a closing bracket. Closing bracket and closing bracket is opening bracket is matching, so I will delete this. Okay. Then I will go to this one. This is also closing bracket. So closing bracket and this opening bracket, it is matching, so I will remove this. You see the beauty of using a stack here. Okay. Then I will go to this closing bracket. Now again, I'm having a closing bracket. I will look at the top of this stack. Top of this stack is having correct opening bracket, so I will delete this. Okay. Then I will move to this character. This is my last character. Last character is the opening bracket. Now, if the last character is the opening bracket, now my string is iteration is over. Okay, but my stack is not empty. Stack is not empty means this is invalid. Did all of you understand, guys? I took a lot of time to explain this. Guys, tell me, stack का concept clear है सबको? हाँ या ना? Yes or no? किसको नहीं समझ में आया? Okay, we will do more questions on stack. Next class we will talk about queue. Today let us stop here only. Okay, then we'll continue tomorrow. Tomorrow we will learn about queue. We will learn about queue. Queue and stack are very, very similar. Okay, if you have understood stack, queue we will go very fast concepts, and then we will focus more on the problem side. Okay, once this is done, then your linear data structures will be over. After that, we will start with either hash maps or we will start with trees. Now, trees we will do a lot of practice. Trees is a very important topic. Binary
में
trees.
जो एल्गोरिथम है मतलब कि स्टैक को उसमें उतना ही पढ़ना है कि और भी डिटेल पढ़ना रहेगा?
क्या क्या?
जो आपने लिंक लिस्ट स्टैक को में जो कॉन्सेप्ट समझाया उसमें उतना ही पढ़ना है कि उसको भी डेप्थ में पढ़ना रहेगा?
डेप्थ में जितना पढ़ना था उतना हमने पढ़ लिया. अब उसका प्रॉब्लम आपको सॉल्व करना है. कॉन्सेप्ट उतना ही है जितना हमने पढ़ा है. पढ़ने के लिए उसमें और कुछ नहीं है. अब प्रैक्टिस करने के लिए क्वेश्चन सॉल्व करिए. 6-7 क्वेश्चन में सॉल्व कर चुका हूँ और 6-7 क्वेश्चन आप सॉल्व करिए. उसके बाद आपको आइडिया लगेगा कि लिंक लिस्ट क्या है. उसके बाद फिर और 10-15 क्वेश्चन सॉल्व करिए, तब आपको कमांड हो जाएगा लिंक लिस्ट के ऊपर. लेकिन खुद से सॉल्व करिए. जैसे यहाँ पे 4-5 क्वेश्चन मैंने सॉल्व किया. ठीक है, इस पे और भी हम लोग प्रैक्टिस करेंगे. जो वीकडेज पे सेशन होता है ना, ट्यूसडे थर्सडे को, तो उसमें हम लोग और प्रैक्टिस करेंगे. Okay, we'll stop for today, guys. Anyone is having any doubt, you can ask, otherwise we can stop.
उसमें थोड़ा सा एक कंफ्यूजिंग है उसका ऑर्डर निकालने का.
किसमें किसमें?
मतलब कोई भी प्रोग्राम मतलब कर रहे हैं तो उसको हमेशा ट्राई करना चाहिए ऑप्टिमाइज कोड लिखने के लिए ना.
ठीक है.
तो वो थोड़ा सा ऑर्डर मेरे को अभी भी थोड़ा कंफ्यूजिंग होता है, मतलब कि ऑर्डर और उसका स्पेस कम्प्लेक्सिटी और पूरा.
कहाँ पे वो आपको एक बार आप पूछे थे, मैं आपको अलग से भी एक बार समझाया हूँ. वो
मैंने
आपको,
समझ में आया लेकिन थोड़ा सा फिर भी
हाँ, तो
कॉन्फिडेंस
आप
मतलब.
कोड लिखोगे तब समझ में आएगा ना धीरे धीरे. आप कौन सा आप कोड लिखो पहले, फिर आप पूछो कि अच्छा इसमें कौन सी कॉम्प्लेक्सिटी होगी. फिर आपने क्या समझा वो आप मुझे बताओ कि आपके हिसाब से क्या हो रहा है, आपके अंडरस्टैंडिंग के हिसाब से क्या हो रहा है. तो आप वो कोड जिस पे आप कंफ्यूज हो, वो कोड आप क्लास में शेयर करो, उसके ऊपर डिस्कस करेंगे, उसको क्लैरिफाई करेंगे. कोई प्रॉब्लम नहीं है. लेकिन आप जो कोड लिखते हो उसका लाइन बाय लाइन अंडरस्टैंडिंग सबसे पहले आपको खुद होना चाहिए. अगर आप कोड लिख रहे हो और आप खुद ही नहीं समझ रहे हो, तो आप उसका टाइम कॉम्प्लेक्सिटी कभी नहीं निकाल सकते. आपको पता होना चाहिए हर लाइन क्या कर रहा है. जैसे इस कोड का अगर टाइम कॉम्प्लेक्सिटी निकालना हो, इस कोड का अगर टाइम कॉम्प्लेक्सिटी निकालना हो, तो कैसे निकलेगा? टाइम कॉम्प्लेक्सिटी एंड स्पेस कॉम्प्लेक्सिटी.
Both are the order of one only.
ऑर्डर ऑफ वन हाउ?
नहीं, ये
आप बताइए।
Popping element, right?
एक ही
सब लोग
Popping.
शांत रहिए। नवनीत आप बताइए इसका स्पेस और टाइम कॉम्प्लेक्सिटी
इसमें
क्या होगा?
एक लूप लगा हुआ है, तो एक लूप है तो वो n टाइम चलेगा, तो इसीलिए उसका ऑर्डर 1 है।
ऑर्डर 1 नहीं, n।
n है, सॉरी n है।
n है। स्पेस कॉम्प्लेक्सिटी क्या होगा?
और स्पेस कॉम्प्लेक्सिटी का नहीं पता।
ऐसे नहीं पता? क्यों नहीं पता? सोचिए ना कि कोड में क्या हो रहा है, सोचो ना। कोड में कुछ एक्स्ट्रा स्पेस ले रहे हैं क्या हम लोग?
नहीं।
कैसे नहीं ले रहे? ले रहे हैं ना। सपोज ये आपका स्ट्रिंग है, ये आपका स्ट्रिंग है, तो क्या कर रहे हैं हम लोग? एक स्टैक बना रहे हैं ना।
हम्म।
इस स्टैक में इसको डाल रहे हैं ना,
हम्म।
तो स्पेस नहीं ले रहे हैं हम लोग।
हम्म।
स्पेस ले रहे हैं ना। ये स्पेस कितना होगा? वर्स्ट केस में इट इज पॉसिबल दैट all the characters will go in the stack. Suppose your string is like this, all open brackets. Suppose this is your string, then all the characters will go in the stack. So space complexity is also linear. Whatever is your string, the same thing can go in the stack. So it is O of n. Time complexity is also O of n because every element you are testing one time. You are checking this, you are pushing it in the stack, that is O of 1. You are removing from the stack, that is O of 1. You are comparing, you are doing O of 1. But that entire operation you are doing how many times? You are doing n times. It is very, very simple. If you understand, see, again I am telling, अगर आपको क्लियर अंडरस्टैंडिंग है कि क्या हो रहा है, हम क्या कर रहे हैं, कैरेक्टर ले रहे हैं, उसको स्टैक में डाल रहे हैं, कंपेयर कर रहे हैं, पुश कर रहे हैं, डिलीट कर रहे हैं, अगर आपको हर लूप का जो विजन है वो अगर आपके दिमाग में मेंटल मॉडल क्लियर है, तो आपको बिल्कुल कोई डाउट नहीं होगा टाइम कॉम्प्लेक्सिटी में। ठीक है, तो इसका टाइम कॉम्प्लेक्सिटी स्पेस कॉम्प्लेक्सिटी दोनों O ऑफ n है। यहाँ पे टाइम कॉम्प्लेक्सिटी स्पेस कॉम्प्लेक्सिटी बोथ आर O ऑफ n। क्लियर? और बताइए। This I will put it in the okay, then we'll stop here and we will continue tomorrow same time. Okay, 4 o'clock we will meet tomorrow. Bye.